Well, hello and welcome back to Isifundi Training and Bite-Sized Corrosion. I'm Vanessa Seeley Fisher, and it's a delight to host today's conversation. Yesterday, we started a 6-session conversation looking at high-tech coatings. Now, whether you're a professional who's working with high-tech things on a daily basis, or perhaps this is a topic you feel you know very little about, we know that you're going to find valuable insights through today's conversation. Yesterday, we spent some time considering the vast array of uses for epoxy coatings. But today, our high-tech coating spotlight, as it were, falls on polyurethanes. And we're delighted to welcome Danie Du Preez of PPG back to the microphone to help us explore these coatings a little. Welcome, Danie, and thank you for coming.
Hi, Vanessa. Thank you. And thank you for everybody joining. It's truly an honor to be invited back. And let's hope we can discuss something that's quite interesting today.
Well, Danie, I'm aware we might be attempting the impossible, but I do hope that as a result of our conversation that our viewers will gain a better understanding of our polyurethanes, although we're not purporting to be selling the be-all and end-all discussion about polyurethanes. But let's kick off today by talking about what polyurethanes are and some of their major uses in the corrosion protection sector.
Yeah, thanks, Vanessa. Like I said in the beginning, I thought when you contacted me, this is an easy topic. Done. And then I got worried we don't have enough time. I think we can really speak for hours and hours on it. And it's not as boring as what we thought, because typically polyurethanes are a bit boring. But so to get to polyurethanes, back in the 1930s, 1937, Bayer actually invented polyurethanes, and it wasn't intentional. It just happened. And initially, polyurethanes were just a polyol and isocyanide that formed the urethane. Really easy. Polyurethane was born. Thank you. There you go. But from there, it branched out. And this actually became the building block for a lot of things in the industry. But for us, in our market, the most common polyurethane is aliphatic acrylic polyurethane. One of the few coatings that actually rolls off the tongue easily. It sounds a bit more exciting than epoxy or zinc phosphate epoxy primer or something. So common one in our market is like I said, aliphatic acrylic polyurethanes. Now, it's an isocyanide and it's a polyol, but this is more aliphatic diols that is used in it, and you get this reaction, and there you get aliphatic polyurethanes. So in today's world, it is mostly a protective and a decorative coating. Corrosion, it's designed to give long-term durable protection against UV and atmospheric conditions, atmospheric exposures. So now it's a coating that's available in a wide range of colors, different gloss levels, originally a final coat for systems, so over epoxies, final coat for what it is. So yeah, it's like I say, it's got very good protection or resistance against the atmospheric conditions, specifically UV, to prevent coatings from yellowing, chalking, fading. The decorative part is there. It's important. We want to protect our assets, but we want them to look nice for many years to come. You don't want a dull structure. You don't want to drive past a building or warehouse or mine, and it's just these dull colors. So from a decorative perspective, very important in our market.
And obviously that attribute is really coming from the fact that they are high gloss and that they have reasonable color retention. They don't fade.
Yeah, that's true. I think that's a very interesting term. The color and gloss retention is, I think, the biggest selling point of it, that effect for UV exposure. And it's something that is tested. So it's not just a selling term or a commercial term. We normally test top coats for color and gloss retention against the ASTM standard, and in this case, G154 that is tested. And it is a standard practice for operating fluorescent, ultraviolet, or UV lamp apparatus for exposure of materials. So long word, very short, it's a QUVA cabinet that we use for that, and we test products and we see how long they would last. Now, normally for us in this is we test the UV portion, a portion of sunlight, moisture, heat, a combination of cycles to accelerate a life cycle of a coating to see how it will hold up. Will it stay in its normal condition? Will it give color and gloss retention? So for normal aliphatic acrylic polyurethanes, we normally say if you can reach 80% over 3,000 hours, you're there. So we plot color retention or color and gloss versus each other. Not bad. Color retention, we talk about delta E. So how much did the color change from the initial sample to after a certain period of time. And that difference or that delta tells us whether it is retained enough color or not. It doesn't speak to gloss on that side. Gloss is separate, but whether you keep your colors. And this is where polyurethanes are very, very good in the market. This is the main use in it.
That is interesting because I think there is that aesthetic appeal. As you rightly say, we don't want our assets to look grotty after a fairly recent recoating exercise. Now, Danie, just to go back at the start of the discussion, you mentioned that polyurethanes were first developed in 1937. That's 88 years ago. And so a part of me is saying, can polyurethane still be described as a high-tech coating in the 21st century? Are there still improvements? Are they making strides?
Let's answer this in two ways. If after 88 years, the coating is still in the market, most probably it is a high-tech coating because it hasn't been replaced. But I don't think that's necessarily fair. I think, yes, it's still high-tech coating. And there's been a lot of developments over the years. And I think if you see polyurethane initially as the building block and you branch out from there into different aspects, from time to time you really find unique things. So I think let's take the past 20, 30 years. Let's not talk 88 years because then we'll be here the whole day. Let's talk 20 years more or less. I think the most significant change we saw was the introduction of zinc phosphate aliphatic acrylic polyurethanes. Still the same old thing as always, but now you can apply it directly to a substrate. And we call it direct-to-metal coatings. So no need for the epoxies we spoke about yesterday. We can never discard them, but now you had the opportunity to go and apply a polyurethane directly to a substrate. And that substrate can be normal carbon steel, it can be stainless or 3CR12s, it can be galvanized substrates, any one of those. And with that, you could increase the total DFT of the coating at the end of the final coat. So not only could you go direct to metal, but if you use the same coating as a final coat or top coat over an existing epoxy system, you can get a higher build, and you've got corrosion inhibitive raw materials in there, which really help you. So that was a very big advance in the business at that stage on polyurethanes. I think the second thing that happened then is we also, after this, we saw the birth of polyurethanes as final coats in our market. Now, when I say our market, let's talk about the protective coatings market in that, because when we say there's architectural coatings, there's industrial coatings, there's automotive coatings, and all of them's got polyurethanes. So if we narrow it down just to structural steel and those type of things, what happened after zinc phosphate aliphatic acrylic polyurethanes was polyurethanes with higher volume solids. So we want to reduce the environmental effect. We want to reduce VOCs in products, the volatile organic contents of them. So higher volume solids, higher build coatings. That was the two most significant things that happened in the past few years in it. And you can apply these coatings in up to a C3 environment direct to metal. So it was unknown. It was unheard of. And the most interesting thing is we had to find a place in specifications in the market for these coatings. You go to an asset owner and say, we've got this product. We wanted to put it in your assortment, and they couldn't find space in specifications. So they had to adopt that.
That's actually a very valid and interesting point, is we encourage asset owners to ensure that they've got specifications that they feel comfortable meet their needs. And yet, as you rightly say, when you bring in a new technology, where does it fit? And how can it still be used without breaking the rules, as it were? And that's, I guess, a client education process that that manufacturers like ourselves need to go through to say your specification says A, B, and C. This is a combined solution.
I think when we talk about innovation, there's two parts of it. There is advancement of existing technologies. So you take an existing product and you better it, and maybe more volume solids, those type of things. It doesn't change the generic binder types. It doesn't change the makeup of the product, but the performance is better. Now, when you have these, let's say, more significant advancements or innovations in the market, like you say, then you need to find where are you going to put this in the market? And asset owners don't always understand it. And the same with consultants. So it does take time sometimes for newer technology to really hit the market and to really find a good spot in there, because it also takes time to convince people. We live in a time where in our market, corrosion is measured over years. So if you now bring a new technology and say, I can really help you, says, okay, show me your track record. No, but it's new. So you're 100% right. Sometimes we need to create new parts and specifications for this. It's easy if the whole market has got the same technology, because then it seems fair for everybody. But when it's one company that's got a specific technology, there's even more resistance to that change, because you take the competitive part out of it. So, yeah, innovation, it's nice, but it takes time to get into the market. You might bring it to market now and only see the result 5 years, 8 years, 10 years later.
Just with the concept of innovation, and without being disparaging about the South African market, do you find that the South African market is more resistant to innovation in products? And do you have an opinion as to why that might be?
I can't say the market. I think sometimes it's individuals as well. I think we've got people that will drive the same car their whole life because they drive it, their dad drove it, their grandfather drove it. So we've got people like that, and we need to respect that. And some of them had bad experiences with changes. Change is not always nice in this market. And our market, change, when it comes to corrosion, can cost you a lot of money. A failure can be expensive on site. Just the downtime, the risk. So there is people that is, let's not say resistant to change, but they might be more conservative in their approach to it. So I think the market has always been very open to new technology. They always want to hear about it. And when you launch something, there's a very big interest. But the change is slow. It's a long chain. The value chain in our market, from top to bottom, is long. There's a lot of stakeholders in it. There's a lot of convincing in it. So no, I don't think it's much resistance. I think for us, the biggest resistance is life cycle costing versus cost of products. We still have that mindset sometimes. We buy the cheapest and we'll paint again in 2 or 3 or 5 years, where you can actually spend a bit more and protect your assets for longer and reduce your downtime, reduce maintenance, reduce those things. So I think it's an approach, but we'll get there. I don't think we're backward against any other market in the world.
Well, that's good to hear. And I would imagine that in some regards, because I presume all of your raw materials are imported, the financial ramifications of changes can be somewhat watering.
Yes, it's nice to say in some contexts all the raw materials are imported, because everybody feels a bit safer. But I miss the days where all the raw materials were actually available locally. It was good when we had a more vibrant market and we had companies that produce raw materials, and the raw materials that were produced in South Africa were of very high quality. So they didn't go away because international companies didn't want to use them anymore. We exported them around the world. So it's a pity that we don't have that many raw material suppliers. So bringing them in, yes, but like you say, the financial implications is big. Some of these raw materials don't have the shelf lives that they had a few years ago. So you need to be careful in what you're doing. You need to do it. But I think most companies have gone for complexity reductions these days, smaller ranges, focus on really key products that can drive change in the market, because everything is imported, unfortunately.
So instead of being the one-stop shop, you focus on where you think that you have the competitive advantage and provide those clients with exceptional service.
Which is a bit of a pity, because we would like to provide, if you look at polyurethanes, if you look at just our assortments, we've got so many polyurethanes, and it would be good to be able to offer them for everybody in the market, because everybody in the market will have different uses, but you can't anymore. But you see it in retail as well. Interesting, people like Pick n Pay, they took off, I think, 28,000 line items out of their shelves, because you can't have 20 different tomato sauces anymore. People don't buy them. You need to only now have 5. So the same in our market. It doesn't mean they're not available. They might not be locally produced anymore, but they are there. We tend to follow world trends, global trends on specifications, on projects. So we keep with the latest technologies. We keep with the latest trends in the market. So it's just now you don't cater for everybody. You cater some more fit for use products that everybody need to adapt to, unfortunately.
Well, I think there's value in that as well, because you get to know your market very well. You mentioned that obviously the broadest classification is going to be your aliphatic acrylic polyurethanes. I know that some people are concerned about polyurethanes because of isocyanate, and that means cyanide, and that means we're all going to die. Can you just talk about, are they isocyanate free is that even a thing? Because you need the isocyanate to create the classic polyurethane anyway. But are they looking at alternatives in that regard?
Yeah, allow me to give you two parts of the answers. I'll get to the products now on whether it exists or not. But let's quickly talk about isocyanates. And if you talk about isocyanates in general, and in its worst form, it's a nasty thing. And a lot of people will say isocyanates will kill you. The wrong isocyanates will kill you. That's true. But the isocyanates that most or all the major producers of polyurethanes use is not that type of isocyanate. It's safer. It's controlled the way it is manufactured. We talk about closed loop systems for MDIs that you manufacture them to make them safe. So the story about isocyanates that's going to kill you with what we're talking about, aliphatics, and the rest of the polyurethanes, no, not true. But this resistance remains. And in a lot of the markets, especially in Europe, the resistance grew up to a point that changes had to be made to some of the raw materials. We call them substances of concern over the past 2 years to avoid specific trainings that all applicators will have to undergo if we want to stick to the older technology. So we needed to make some advancements in it, which we were able to do. It's not going to go away. It is old. We talk about 88 years ago when it started. Aliphatic polyurethanes has been around for a while. So are they nearing the end of their life? It's not for me to decide. The market will decide that, but they've been around long. So do we have isocyanate-free coatings that is safe if you want it? Let's just talk about isocyanate-free. Yes, there's two main ones. That is. So the first one is the normal type of polyurethanes where we remove it. And the only difference in that is, then we're going back to yesterday's discussion, they actually become an epoxy at that stage, but they are UV resistant. They can be exposed to atmospheric conditions. They still have good color and gloss resistance and retention. They don't yellow and fade and chalk like epoxies would, because this is still a final coat in it. So yes, we talk about isocyanate-free coatings in it, and those isocyanate-free coatings exist. It's quite big in the UK at this stage. They've replaced most of the aliphatics in the UK. In South Africa, not yet. A few years ago, there was one or two specific OEMs that used them, but they haven't been adopted well. The other one, strangely enough, is the Rolls-Royce of the polyurethane coatings, which is polysiloxanes. There's also no isocyanates in it. But we'll speak about polysiloxanes a bit later. Let's not take that on them. But yes, Vanessa, it's going to happen. We're going to end up moving there. The world's becoming greener. We need to look at the environment. That is very, very important for us. We don't just look at profits anymore. We need to look at people. We need to look at the planet. And for that, we're going to move to different types of coatings, different types of technologies. And when they adopt it, eventually they'll become cheaper. Sometimes the adoption phase makes them a bit more expensive.
Fair enough. Now, sticking with the green concept, VOCs, or your volatile organic compounds, are pretty much a hot potato. We hear about the use of moisture-cured urethanes, particularly in the industrial markets overseas. I'm not hearing about them so much here. Are my ears blocked, or are we being quite slow to adopt them?
I think moisture-cured urethanes, we need to be very careful in that terminology. It's not just what it doesn't make it green. It's just the curing mechanism in it. If you look at zinc ethyl silicates, they're moisture curing. It doesn't make them a nice coating. It's still a zinc with heavy metals in. So I don't think we should necessarily focus on one term for a chemical reaction for curing, because I think it can be misleading. It can be, and we use moisture curing. It gives the wrong impression. It's not. We don't want moisture in solvent-borne coatings. It's the wrong thing, but it can be used as a vehicle for curing purposes. So by itself, no. I think we should look at the generic binders of the coatings more than look at specifying or saying moisture curing only.
Fair enough. Then if we're talking about the coating and its actual application, I'm assuming because it's a high-tech coating, these polyurethanes are not going to be mixed with the stick and use a roller to get it onto the substrate. I presume it's going to be something a little bit more fancy than that.
Will you allow me just to jump back one question, if
Sure.
you don't mind, about some of the technologies before we get to the application on this? So there's this gap that we haven't bridged. Where are we going in this? And I think it's because I backpedaled one of your previous questions. Where are we going with the better technologies? You've got products like polymeric urethanes, which is very unique, which is very high durability, longer gloss and color retention, better flexibility, durability of up to 20 years on those products, color and gloss retention of up to 20 years, life. So That's brilliant. Those things are available, and higher volume solids, so already lower VOCs, it speaks to that. But if you really want to talk about where this should go to, it's polysiloxanes at this stage in the market. That's the ultimate coatings. No isocyanates in it. You can do it direct to metal. Best performance as a top coat. 25 years plus life expectancy. Brilliant in even CX environments. Yeah, you can even anti-graffiti on it because the graffiti doesn't stick to it. So there's so many advantages. Yes, it's expensive, but this is the coating of the future. When you talk about polyurethanes, where this is branched out, it is that. And then there's another one. There's a niche one. There's a polyaspartic. Polyaspartic, very interesting, slow. That's one of those things we spoke about. Innovation that didn't adopt. It didn't adapt everywhere. Not the easiest coating to apply. So now to get to your application, maybe that's what's killing polyaspartics. Difficult sometimes to apply in maintenance and repair environments. But the rest, you asked ratios, and we need to be careful. I almost want to say with normal polyurethanes, you don't have to. They are quite forgiving because they are designed for maintenance and repair markets and not only new builds where you apply coatings in factories under controlled conditions. Is brilliant. These are out in the field. It's somewhere on a stack. It's somewhere in a mine but if we go back, we want to adopt best practices, best quality control in the market, because that gives you the longest life. That gives you the best performance of coating. So we should stick to the mixing ratios. We should stick to practices, mix them well. And, as with anything else, surface preparation, whether it's bare metal, whether it's the previous coat, most important thing. If you get that right, you can do a lot more with your coating. If you do that badly, your coating cannot perform well in it. Quite easy to apply, most of them, brush, roller, spray, any type thing. But we don't like part mixing. Nobody likes it. When you write a specification, you don't like it, it happens. So if guys need to do part mixing, weigh the coating out, use a mixing cup, use something to, if you use this gluk method where you look at it with your eye and that's 2 drops and 1 drop, no, that doesn't work. That's a failure. You're mixing a failure there. You're not mixing a polyurethane anymore.
I like that analogy, actually. If you don't mix it in the correct ratios, you're actually mixing a failure. I think that's a brilliant description, because I think a lot of times the training to the applicators has not been adequate, because I think if an applicator, someone took the few minutes to just explain why it is so important. No applicator wants his work to fail, just like none of us want our work to fail. And I think if we took some time to educate the applicator as to the criticality of what they're doing, they may actually get a better product at the end of the day just because they're taking more care, because they understand why it's important.
Maybe we should also adapt a little bit in our specifications to make maintenance and repair a bit easier. We specify in it a 2-component aliphatic acrylic polyurethane if we talk about the normal ones. But there is single component polyurethanes that you can use for touch-ups. So because these coatings don't travel well, there is a lot of damages, mechanical damages and those type of things on polyurethanes. So you need to do touch-ups. Now, why do you want to catalyze a 5-liter set to go and paint half a liter? Doesn't make sense. That's when people start doing part mixing. That's when we now start breaking the rules to be practical on site, but we don't. We should maybe extend our specifications right in. Single component polyurethanes, they do exist. That's another innovation that works well in the marine environment. It's brilliant. Use them. You don't have to part mix. You can take your 5-liter up your ladder and bring it back. It's no problem.
That's a very good idea, Danie. Definitely something that I personally will take away from today's conversation. So thank you for that. We've mentioned a couple of the benefits or the strengths of polyurethane coatings, maybe not the strength, but they do obviously have strength. They're quite flexible, and I think that's probably quite a big plus for polyurethanes. But I also think we should perhaps highlight some areas where they're not the right product, because I think it's always important to have that little counter that we know. Have you got a couple of options that you'd like to share with us?
What's the negatives of polyurethanes? There's a long list of those as well. We don't want to say it, but it is there. And then there's places we shouldn't use it. So just quickly on the negatives, it is a thin film coating. In comparison to epoxies and things we specify, polyurethanes are thin, like anything 50 microns, 60 microns. Now the higher volume solids, 80, 90, 100, 120 microns. As a final coat, being flexible, you don't always have all that durability for mechanical damages and things. So it is there. You do not get good DFTs, brushing and rolling polyurethanes, no matter what you do. So you're going to continuously do it. Our maintenance and repair market likes brushing and rolling. These coatings spray better because it's a thin film. So incorrect application equipment. wrong rollers that you use, very bad performance in it. But the correct rollers is a bit more expensive than the cheaper ones, and the cheaper ones don't give you the performance. You're actually wasting your time buying a cheap roller because you're going to redo the whole surface in it. The other thing is we've lost opacity over the years in them because we had to remove heavy metals, specifically lead, out of the stainers or the colorants that we use to create the color in it. So when you remove lead, you lose opacity. So at the same DFT, you've got less hiding power over the years. So it makes it more critical to apply correctly to get the build up. Way to avoid. It's good for splashes and spills, even chemicals. But if you spill acid on it and you leave it, it's going to discolor it. It's going to burn through it. If you wash it and you clean it, then it's fine. I think we want to use it in too many places. We use it inside plants. This was an atmospheric coating. Now we use it inside. It makes a plant look nice. It gives color. We can also use it to identify acids. Tanks, pipes, what's the cargo in a pipe? I think it's just, we must always bear in mind, this is still a maintenance coating. It's good for maintenance. So if it gets damaged, touch it up. If you spill acids on it and you've cleaned it and it's faded or it's dull or it's lost color, just repair it. It's the coating that repairs the easiest. Most of them has got, and I say it carefully, unlimited overcoating. So with very little prep, you can actually apply a second coat. So very easy for maintenance. So don't worry not necessarily about some of the damage. Just touch it up. It's designed for that. But I think it's not the biggest impact coating. It's there for decorative purposes. It's there for protection. And used in the right environment, it's brilliant. But like anything else, if you use your BMW to go rallying, you're going to pay the price.
Thank you very much, Danie, and thank you for spending time with us today to help us explore polyurethanes a little bit more. You certainly opened my eyes to some different applications, and I know that we've barely scratched the surface, but our time is out. But I do hope our audience feel that we've helped them to broaden knowledge and at least know something a little bit more of what you didn't know before. Thank you.